Another issue that your code can cause is a shuffle. We're going to talk about what shuffles are and how you can mitigate these shuffles in this particular lesson. So a shuffle is the result generally of a wide transformation, things like join, distinct, group by, order by, and they cause data to be moved around in the cloud service provider and essentially slow down your queries. And honestly, some actions can cause this as well, things like count. So what is a shuffle? Here's a two-stage job that's required, where one stage needs to be completed and data generated at the end of the stage, some transformation or something that's happening, and stage two, which will happen after stage one has completed. Now, we're going to look at a map reduce and how this can be applied through these two stages. So first, the data is read into stage one. We map and perform the map transformation, and then we have data that needs to be moved into the reducer. So now we shuffle because that map has caused us now to have data that needs to be moved into stage two based on that specific mapping. And then we finally, now, of course, this is crazy, right? We're shuffling this data all over the place. And this represents network movement from one worker to another. So as these workers perform specific tasks, we have to move things around the network at the cloud service provider, and that's a shuffle, right? So then we have the reduce, and we end up with our outputted data now, and our outputted data then needs to be written to some data frame or a table, whatever it might be. And so we have stage one, stage two that completes, and in between now we have the shuffle. And this is a result of essentially the aspect of data being assigned based on that map that is occurring in stage one, and then being reorganized so that it can be pushed through the reducer function. So how then do we mitigate shuffles? We can reduce network I/O by using larger workers and having fewer of them, right? So we can essentially, if the workers are doing more work because they're larger and we don't have as many of them, then by definition, we're going to reduce network traffic and mitigate shuffling. We can also use SSDs and other things that will speed up reads and writes, because if we're doing that, then we are going to reduce the amount of time that a shuffle requires. We can reduce the amount of shuffled data by removing unnecessary columns or filtering out unnecessary records. We can denormalize data sets, especially if we're using a join that's causing a shuffle. We can reevaluate our join strategy. We can reorder the join as needed. We could dynamically switch join strategies, use broadcast hash joins, shuffle hash joins, or sort merge joins. Again, the default for Databricks Photon is the shuffle hash join, and the default for OS Spark is the sort merge join. And these are all things that we can implement to mitigate our shuffling.